Hello, and welcome to Theme Thursday here on Answer Everywhere. I'm coming to you live, as always. This is a show where we open up a source code repository and peek around and try to figure out what's going on in it. For the past couple of weeks, we've been having on Theme Thursday the theme of Haskell build systems, buildy or compile-y things for the Haskell ecosystem. We looked at long ago. We looked at GHC, which is not part of this particular theme series, but then we looked at Hadrian, a build tool for the GHC compiler, and then last week we looked at Cabal, which is a packaging and building environment that is core to how Haskell packages work. And today we're looking at Stack, which, if I understand correctly, is built on Cabal and tries to make a nice user interface to Haskell packaging. I'll add my usual caveat, which is that I am not a Haskell developer. I've played around with Haskell. I read some books about Haskell, done some tutorials, that sort of thing. But I'm not an expert. And I think you'll see that in this video. And I'm not even sure that I've used Stack directly. I've certainly used it indirectly via tools that call out to Stack or that use Stack under the hood. So I'm curious to see what's going on and how it does things. All right. And before we look at the code, some administrative stuff. I posted my schedule, which I think is now behind the screen. There we go. So I've got 2 weeks of schedule up now, and we're continuing with the theme days as we have been for the past few weeks. And starting on next Monday, we're going to look at gRPC Haskell. Meme Gen Monday is about things in the Google ecosystem. gRPC Haskell is a third-party tool. It's not written by Google, but it is in the Google ecosystem, and it's kind of tying off the end of the Haskell theme as well. Then on Tools Tuesday, we're going to look at React, the Facebook framework for making web apps and that sort of thing. That was also a fan request, but when the fan request was made, it was already on my schedule. So that's why it's not showing up on fan request Friday. And then Network Wednesday, we're looking at Wireshark. And on Theme Thursday, next Thursday, we're gonna close off the Haskell build tool stuff with Rules Haskell, which is Bazel support for Haskell. So the ability to build Haskell packages with Bazel. And then on Fan Request Friday, in kind of a continuation of the previous Fan Request Friday theme, which was where we looked at Brave, we're going to look at Firefox UI code. How is this a continuation? Well, for one, these all came from the same request, which was kind of like a multi-part request. But the idea of the request was to get a sense of more of a sense of browsers, to learn more about how browsers work, and including things like UI code. I don't know exactly what part of the UI code we'll focus on, but potentially the HTML rendering code. And then for the following week, the week of April 10th, on Meme Gen Monday, for the Google ecosystem, we're going to look at Garrett, which is a code review system developed by Google. On Tools Tuesday, we'll look at Git, the omnipresent version control software. On Network Wednesday, we'll look at IP tables. And on Theme Thursday, we'll start a new theme of language server protocol implementations, and we'll start with Rust LSP. This was also a request from a comment, but I'm sneaking it into Theme Thursday. I guess I won't do all of the fan requests on Friday, otherwise I'll never get to them all. And then on Fun Friday, for the week of April 10th, we'll look at Ardour, the multi-track music recording software for Linux. So that's the schedule. And there's many more in a provisional schedule that is secret to me, but which I may make some version available in the future. I thought I minimized my browser, but I seem to have closed it. What? Okay. Let's pull back up Stack. All right, so here is Stack. And what do we have? We've got a link to the webpage, of course. Some releases. Latest release is December 2022. That's pretty recent. Languages, mostly Haskell, Shell, Dockerfile, Emacs Lisp. Emacs Lisp. I probably just whoever developed it uses Emacs and maybe committed some of the config and some make files. There's also a README. Their documentation, if I recall, is very good. But on the show, we don't really focus on documentation, so we're not going to look closely at it unless we need to resolve some problems. And then in the main directory, we have a bunch of the like metadata files, kind of files that configure the behavior of the repository rather than files that are part of the source code of the project per se. So things like lint, I think hlint is maybe Haskell lint. A git ignore, docker ignore, read the docs config, presumably to build the docs and upload them to read the docs. Stan, I think, is maybe a Haskell tool that I forget what it is. And a bunch of Cabal stuff, including a Cabal project. And a Cabal config, which we will look at now that we've looked at Cabal. And make docs, package.yaml, stack.ghc, and stack.cabal, stack.yaml, and a lock file. Cool. And so we're going to start with test, I think. Then source is obviously the place to be. But before I close this main tab, I'll take a quick look at C to see if there's anything here. So we have Docker files and scripts. Docker files, I assume, are Docker files of interest if you're maybe working with CI or running some stack thing in a Dockery environment, but we're not, so we'll ignore that for now. So we have things like hlint as a shell script, build stack installer, CI, presumably continuous integration setup. Okay, so these are we're going to ignore these. These don't seem to be required for understanding what Stack is up to. Here's the cabal.project, and I'm just looking at this to get a sense of, is there anything in the dependencies or whatever that's interesting? And no, there's not. We're just going to import cabal.config, and I guess say that we want the 9.2.7 compiler. I don't know what that means. Like, I don't know how recent that is, so we're going to look up not the global hybrid cooperation. The Haskell compiler. So stable release is 9.4.4 in December 2022. So this is not far off, 9.2.7. Okay. Here's cabal.config, and this is going to be just a list, I guess, of the dependencies. We should see all of these dependencies show up in some of the files, but I'll just I took a quick gander. I saw X509, which is going to be some cryptography or certificate related. We need YAML, as always. Unicode, Unix, Unlift IO, possibly some monad stuff. UUID types. I don't know if that's different from, if it was just called UUID, I would just assume it's UUID support. UUID types sounds a little bit maybe mysterious, but I'm not sure. Let me check something here. Okay. And what else? Text metrics. TH expand, I guess template Haskell. Whatever these is. And TLS transformers, typed process. Okay. Typed process might be interesting. I'm going to actually look up what typed process is. I wonder if I have like a hackage search here in DuckDuckGo. Typed process. Okay, just run external processes with strong typing. Okay, so out of curiosity, what's UUID types? Type definitions for UUIDs. Okay. Maybe it's, I don't know. What is there a UUID without the types? Is this just the type definitions? Okay. Are these the same author? Yeah, Antoine Ladder. Okay. I'm not sure why. Maybe this is somehow more lightweight, that if you need to use the types but don't want to pull in everything. Okay. And STM is that software transactional memory, I think. Stack. Aren't we in stack? Is stack depending on itself? And some, I guess, maybe runtime system RIO. I'm not positive what that is. Pretty primitive parser combinators. Okay, so we've got parsec and parser combinators. Some network stuff. Mustache, probably for template population. Micro lens. Lens is, I know, a pattern or a library. They're for kind of like, I think, peeking into records in Haskell. And then microlens is presumably a small implementation of it. Let's actually look up lens. What was I doing? Hackage. So this is things like, yeah, like things like folds and traversals as well, I guess. Let's see how they describe it. I'm just curious what it's a, with many useful lenses, but I guess we're supposed to know what a lens is. It's related to optics, like functor optics and all that stuff. But I don't think I'm going to like off the top of my head try to explain what that is without, I don't want to get myself in trouble. Okay, so fast logger, kryptonite, cookies, conduit, I think is a like pipes, like kind of like streaming networky stuff, streaming data processing library. Okay, so it's like a streaming data stuff. Co-monad, presumably the co-version of a monad. Case insensitive, whatever CASA is. And Blaze Builder, Blaze HTML, async, ASOC, maybe association lists or something, arrays. ASON is a popular JSON library. I don't know what one tuple is, but quick check is a testing library, and then Cabal and Cabal syntax and glob. So there's a mix of stuff, and some of it seems to be like Haskell containers or things like lens that are useful for operating on Haskell data structures, and some of them are like support for common tools like JSON or YAML. Since we have conduit and software, and what I think is software transactional memory, and in fact, this is STM chans. Sounds like chans is probably channels, but I'll double check this. So there might be some fancy Haskell in here. Software transactional memory. Yeah. Okay. Cool. All right. So that's the dependencies. It's, giving us a sense of what might be going on. So here's tests. We have integration tests and package dump. I don't know what package dump is, but we'll just check, like sanity check the integration tests. So package dump is a bunch of text files that are named after the GHC compiler. We have a description. GHC's functionality can be useful for more things than just compiling Haskell programs. Important use cases are programs that analyze and perhaps transform Haskell code. Others include loading Haskell code dynamically in a GHCI-like manner. For this reason, a lot of GHC's functionality is made available through this package. Okay, but I don't know what this file is doing. And then we've got Haskell line. I guess this is just dumps of packages. Maybe these are dependencies. And I don't know why. This is in test, right? So maybe maybe they're testing that these can be deterministically generated on like different runs of the like the CI system or whatever. So we have integration tests. A bunch of integration tests for Stack. Each directory inside the test subdirectory represents a single test. And each of them has a main.hs file and a files directory. Okay, how do you run them? Call stack build and something to run the tests. Okay, so how many are there? I guess is my question. A lot. Yeah, okay. This looks like I'm gonna guess this is pretty thoroughly tested because there's a lot of tests. I'm not gonna look too closely at the individual tests. And here we are in stack/source, which is I think we know at this point this is where the meat of Stack is going to be. So let's see what we have here. We have control/concurrent, which might be the most interesting thing, just from a curiosity point of view for me. Maybe not for you. I think that I think because of laziness, some of the performance characteristics of Haskell are at least maybe harder to understand, harder to reason about if you have at least if you have your brain configured to think in terms of C or C++. But I think some of that some of the difficulty is also a little bit intrinsic, because if you have like a lazy function, then the behavior of that function really kind of depends on what data you're pulling out of it. And it might be the case that, if a client has like a certain kind of behavior, then it like throws everything into chaos. And that's hard to detect unless you have a lot of, I guess, integration tests that test, common client strange behaviors. Clients might do things like, you might have a lot of clients. If your Haskell package gets shown on like the national news and everyone starts to download it at the same time, you might suddenly see a spike of clients, and that might be unexpected behavior because you're not tuned to handle that. Or you might have a client that retries too aggressively, or forgets that it's connected to you and like falls asleep or whatever. There's all sorts of stuff that can happen. And if that happens, either at scale or when you're not expecting it to happen, then things can go haywire. And those might be the sorts of situations where laziness makes it harder to predict how the overall system is going to respond. And so I think that that's one of the harder parts of Haskell. Maybe if you know Haskell and what I'm saying is just totally wrong, please let me know, because this is the impression I have as an outsider. Okay, so we'll look at concurrent, but before we get to concurrent, I want to just see what else is here. So data, I guess that could really be anything. Network HTTP, I'm going to assume is mostly straightforward, but a big part of Stack will be like downloading packages from places, maybe from Stackage, which is maybe stackage.com. I'll just look for Stackage Haskell. Stackage is like a repository for stackage.org of Haskell packages that are kind of like frozen together and are known to build together well. So the idea is you like kind of have like a snapshot of all the packages, and as long as you don't change that snapshot, things won't break. And then when you do change the snapshot, presumably you're aware that you're bumping the snapshot, and you might expect breakages and that sort of thing. Let's see if they have a FAQ that's worth checking out. Why is it all an older version of GHC? Older versions of packages, how do you maintain an LTS build? Okay, what time hey, right. Yeah, so that's my understanding of Stackage, at least. and it's in the same whatever you call this, or maybe organization on GitHub. So commercial Haskell seems to be people who are trying to push forward, I guess, adoption of Haskell in industry, if I understand them correctly. Okay, so network HTTP options applicative. That's going to be presumably things like applicative, but in Haskell, so it's going to be more algebraic type stuff. I would imagine. Maybe they stuff it all into this directory, or maybe these are just some of the applicative tools. Path. I'm not sure why that gets its own directory, but I think so. Stack, I believe, does some sandboxing, so maybe they need a lot of routines for manipulating paths and knowing like what the sandbox version of a path is, etc. Stack itself, which might just be like the main entry point, system slash for like the stack primary libraries or whatever. System process, that could be interesting. That might mainly just be about calling external processes, or maybe like forking different processes. So main, setup, shim, test, Unix, and Windows. We're going to ignore Unix and Windows. We will look quickly at test. And there's more tests in here. These might be unit tests instead of integration tests. So we have things like GHCI spec tests. Yeah. Okay. So just seeing if there's anything here. So spec is like a Haskell testing thing, right? HSpec, a testing framework for Haskell. A friendly DSL for defining tests, etc. Integration with quick check, small check, and unit. Parallel test execution and automatic discovery of test files. All right, I don't know if this is HSpec or if this is some other spec, but test HSpec. Yeah, okay. Cool, lots of tests. I love to see that. We're going to definitely open main. We're going to definitely open stack. And then I personally am interested in control and concurrent. I feel like we should at least know what's in HTTP and process. And then look at applicative. And then I'll also look at path and data, I guess, first, with the goal of trying to close them quickly and rule them out as especially interesting. So path has check, install, extended, extra, and find. Find is presumably going to find stuff. Extra, who knows? But these don't look like they're the most exciting thing. And I think I was opening data, but it may not have. I may not have successfully clicked on it. Here's data. Okay, we got addo parsec. Parsec is presumably the parsing thing. Addo, I don't know. And then we have a monoid. Let's see what monoid is. Data.monoid map. The utility wrapper to make maps monoid also use the elements monoid. Okay, so something with monoids. Okay. So monoid is not a monad. I don't know what people use the monoids in Haskell for, but map has one. Is map, I don't know if map is supposed to be like a hash map, like it maps keys to values. And we have a monoid map. Did we look it up? Yeah, let's look it up. Oh, okay, wait, hang on. This is instance ord k semigroup A. So this is a semigroup, which makes sense. So monoid of monoid map where m append, so you can append, and empty. So you have the append and empty. Is that the interface to monoid? That should be the interface to monoid. The monoid type class, not to be confused with monad, is a class for types which have a single most natural operation for combining values together with a value which doesn't do anything when you combine it with others. Yeah, it's a monoid. And it's part. They're considering it part of a semigroup, I guess. So let's see if we could just look it up in math notation. Yeah, that's a set S equipped with a binary operation from S cross S to S, back to S, which with we denote the binary operation as like bullet or circle dot, and it's got to be associative, and there's an identity element. So it's like a like a degenerate group a little bit. Maybe that's why, yeah. So there's like a couple of classical examples, like natural numbers under addition. So you just have, as you're counting, that's basically a monoid operation. You just moving in one direction. You can append, you can't unappend, and you can't really like seek into the data structure at all. So that's what a monoid is. Okay, so here's main. Wait, did we close out? Okay, we closed out data, right? Is that what we did? What was even in data? Was it just the monoid stuff? Let's do this again. Yeah, just attoparsec and monoid. I don't know why it's in data. Doesn't seem like that is, it doesn't seem like that stuff is data. Maybe it's for working with data. So main.hs and buildinfo.hs. Buildinfo is presumably like the version files we see in some of the C code, just metadata about the build. So I'm going to ignore it. And then main, let's take a look at just how big main is. Sometimes main is huge, sometimes it's not huge. All right. Over 1,000 lines of code. All right. We've got a bunch of stuff with commands, including init command, new command, templates command, list command. They all return an RIO runner of the empty type. So maybe RIO runner together is like a monad. I'm going to say mono. I'm going to mess up saying monoid and monad now that I've said monoid so many times. But this might be a monad. And I don't know what RIO is. Something input output. IDE packages command. So let's just take a look at a simple one. List packages in the project. So IDE packages command has a type. It's going to take a tuple of IDE output stream and IDE list packages command. And it's going to return an RIO runner with this empty type thing. And that might just cause a side effect to happen. I'm not sure what RIO runner is. Maybe we can find out. But the IDE packages command is just going to call with config, no reex, presumably don't re-execute, composed with build config, and composed with uncurry of IDE list packages. All right, so this is really just list packages with some mumbo jumbo to get it into the right type, I guess. Let's see if we can find out what RIO is. So import RIO process. Do you have a guess for what R might be? I don't. RIO, a standard library for how a standard library. I don't think it means like a standard library, does it? So it's got the same guy. I've seen this guy before showing up in the other. I think Michael Snoyman might be the possibly the creator of Stack. Look up Stack on Hackage and see if he's the author or whatever. Okay, so RIO, we get some docs. What does it have? It's got lenses, byte strings, prelude stuff, processes, seek, SEQ. I don't know how people pronounce that. Seek. And he's the package maintainer. So a standard library for Haskell. But what does it do? I'm not sure what it does or what its main selling point is. How about the README? Here we go. No. The goal of the RIO library is to make it easier to adopt Haskell for writing production software. It is intended as a cross between a collection of well-designed, trusted libraries, useful prelude replacement, a set of best practices for writing production-quality Haskell code. That's the end of the list, and then this is what's in the library. Okay. All right. So while GHC ships with a base library, as well as a number of other common packages like directory and transformers, there are large gaps in functionality provided by these libraries. This choice for a more minimalistic base is by design, but it leads to some unfortunate consequences. For a given task, it's often unclear what is the right library to use. For writing libraries, there's often a concern about adding dependencies to any libraries outside of base due to creating a heavier dependency footprint. Oh yeah? By avoiding adding dependencies, many libraries end up re-implementing the same functionality. Yeah. And then it quotes this popular XKCD about proliferating standards. Okay, so RIO does seem it is trying to be like a standard library in the sense that like a programming language has a standard library. And then what did I say I was going to do? I was going to look up stack to see the whoops. Should probably spell it correctly. Okay. Oh, so Michael Snoyman is here, but not at the top, and this might not be alphabetical. I don't know what the order it means. Might mean nothing. It might mean that Chris Dunn is like the chief maintainer or whatever. I don't know who started it, the stack project that is. Okay, cool. All right, so let's go. So we were at main. So RIO is, we're gonna just treat it as like a prefix for that standard library stuff. What else do we import? Conduit. This addo parsec stuff. A bunch of stuff from data, like essentially. Oh, yeah. So that folder was called data because that's a popular. I often forget that in the Haskell world, I'm not positive this is how it works, but I think you can like add your own. You can release your own like data.foo, and it's unrelated to the other data libraries. So this prefix is kind of like telling you what shelf of the library your book is on, but all of the libraries under a prefix might be of like wildly different authorship or standards or quality or whatever, I think is how things are in Haskell. Let's look that up. Let's see, Haskell package naming. Is there any standard module namespace naming convention? Maybe this is the place to be. I'm basically from Python world, and I've been playing around with Haskell for a few days. As a Python user, namespaces of libraries from Stackage was the most confusing. For example, in Python, we will import Scotty, like import Scotty, while in Haskell we do import web.scotty. Haskellers who upload their libraries on Stackage or Hackage seem to prefer putting their libraries under namespaces of a category, for example, web libraries. This is basically what I was saying. Leaving whether it's a good approach or not in perspective of dependency control outside of discussion, is there any de facto convention on this categorization? And the answer is this the only answer? Okay. The package name, the package tags, and the module names are all independent things. The package name is an arbitrary identifier, as long as it doesn't clash with anyone else. It's conventional to make it all lowercase with hyphens between words. Okay, that's like the thing you look up in package maybe. For example, LLVM base. All right, manual package names. Okay, blah, blah. Stuff about capital letters. The tags are used to help sites like Hackage organize the list of packages into useful groups and have no other significance. Within a package, there will be one or more modules. These are what the client source code will import. Okay, so modules exist in a hierarchical namespace. So for example, the parsec package includes the module text.parsec.combinator. You can think of the dots as akin to Linux / yeah, okay. There are a few top-level conventional module names, such as control, data, text, and system. Yeah. Okay. So yeah. So that's how Haskell works. I do find that a bit confusing. What do they do in Java? In Java, they do like reverse URLs, don't they? So it would be like, okay. So in C++, let's say like Twitter or whatever, their library might be like Twitter, and then foo for their library foo. In Java, it would be like something like com.twitter.foo or whatever. It has this like reverse URL thing. Then in Haskell, what the first thing is depends on the kind of library foo is and not who authored it. So that's a different convention it's a little bit confusing because I'm used to assuming when I code that things with the same prefix, packages with the same prefix are similar to each other in a useful way, and that assumption doesn't seem to hold in Haskell. But maybe if you program Haskell enough, it doesn't matter. Anyway, that was just kind of like a detour. And we've got some encoding stuff, options, applicative. Let's look at what the applicative stuff is. Parser failure, parser help, parser result, just parser stuff. Flag, handle, parse result. This is all parser stuff, I guess. Help, error, IDM, long, metavar, maybe metadata variable, over failure, render failure, string argument, and switch. More applicative stuff with flags and help stuff. Applicative.complicated. Okay, add command, add subcommands, complicated options. And then a bunch of stack stuff. Okay. We have main exception, a type representing exceptions thrown by functions in the main module. All right. And this is not, this is, I think you would consider this a union of an invalid re-exec version or an invalid path for re-exec, invalid path for exec. I know in Haskell, oftentimes you get this kind of like left-right thing where I forget whether left is the data value and then like maybe right is the error, which is basically the same pattern you have in Golang, right? So in Go, it's common to return two values. One is the real value and one is the error. And then you check you look at the error value, which is usually on the right in Go, and check whether that's nil or not before doing anything. And then in what's it called? Abseil. Basically have the same pattern, right? Let's see if I can look up Abseil. Status or, yeah. This is the thing I'm thinking of. So like in Abseil, you have like C++, but it essentially returns, you essentially return two values. You return foo if there's not an error, but then if there is an error, it's a status. And you check if the result is okay before doing something. So basically the same pattern as Go, and basically the same as the Haskell left-right pattern. What is that called? Haskell error left, right. Arrow might be one library that does that. Either. Yeah. Handling errors. Okay. Either some error A. The type indicates that an error is common, but doesn't mean that your program is broken. All right, but it looks like maybe in either the left is the error, which I think has to do with compositionality in like the algebraic sense. Whereas in Go and I guess C++, the Abseil libraries, the error is on the right. I think that's right. Anyway, that's what I'm saying now. All right. So then we've got some more stack stuff, system IO. Okay. More exception stuff. Pretty exception. Maybe this is for pretty printing. Run by functions like main module. More exception stuff. Handling exit code, and we have command line helper. Or maybe the command stuff on the bottom might have been command lines. So this is like parsing command lines. This is I've seen this before in Haskell as the kind of like algebraically building up a command line parsey thing. And I don't remember what it's called. I'm sure there are several versions of it. But, you can see what it's doing. It's got a name for the command. Oh no, this is the thing to do. It's adding a command, and then the name is uninstall as a string, a doc string. The command is called uninstall command. Some annotation that it's pure, I guess. And that's it. Okay. So this all seems to be command line option parsing. And then we have secondary command helper. I'm going to guess that all of this stuff is really about parsing commands. And that main is just setting stuff up as an entry point, parsing commands, and then getting out of the way. Okay. Here is, we're just back at the stack directory. All right, setup command, stdist. Let's look at runner. Maybe path.hs. Nix.hs, I guess so. Hoogle. Yeah, I'll look at Hoogle. IDE.hs, that might be important. Coverage. Sure. Build plan, absolutely. Then we have things like type, storage, setup, options, GHCI, constants, config, and build. So these, I think each of these directories is reflected in a file already. And I'm basically treating these files that are not in directory as the same way I would treat C++ headers, as essentially an entry point to the API. And then these folders, I will just imagine them to be basically implementation details that we can dig into if we want to know more, but I won't. In the first pass, I'm not gonna open them up. All right, let's see, what do we got? Here's runners.hs, utilities for running stack commands. Instead of, okay, so stack has a bunch of commands, things like build, test, maybe like download in the background, stuff like that. Instead of using has style classes below, the type signatures use concrete environments to try to avoid accidentally rerunning configuration parsing. For example, we want with config, blah, 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 with config to fail. We want with config, $, with config, $, at to fail. Avoid accidentally rerunning configuration parsing. Okay, cool. Actually, I'm going to check something real quick. Cool. Right, I'm back. All right, so I don't know really what this is saying, but something about avoiding accidentally rerunning configuration parsing. And maybe the way to think about that is parsing is not, parsing is something you want to do once. So I guess you don't want to accidentally call the parse function twice. It's not idempotent or whatever. All right, so you import more RIO stuff, some stack config stuff, stack prelude, a type representing exceptions thrown by functions. So we get more exception stuff. And what do we have? Instance exception, runners exceptions, where display exception, command invalid, Docker and Nix invalid, Nix within Docker invalid, can't use Nix from within a Docker container. Cannot use both Docker and Nix at the same time. Cannot use Docker from within a Nix shell. So what's going on? I'm not sure, but if I understand correctly, Stack does sandboxing. So it kind of does like a sandboxing cabal stuff under the hood. And then there are other sandboxing projects, one of which is Docker, which is essentially a nice way of configuring C groups. At least that's how I think. That's how I think of it. I don't know if that's the 100% accurate. And then Nix, which is this package manager, this functional package manager, similar to the Geeks system that I'm using, but predating Geeks, and Geeks uses Nix. But at any rate, they're all kind of, they sort of achieve similar ends of trying to sandbox like a developer environment or a run environment so that it always behaves the same way, and so that it doesn't monkey about with whatever the host system is. And these errors are telling us that you can't combine the sandboxes in certain ways. So if you're using Docker and Nix, that's not allowed. Hello. Hey, Aporv. And you can't use Nix within Docker and so on. So I'm not sure why that restriction is, but it might be related to the fact that they're going to choose a sandbox, and it's unclear what should happen if the sandboxes are all interacting with each other. All right. With global project, with env config, so some sort of environment config, whether we should re-execute. If the settings justify it, should we re-exec inside Docker or Nix? Load configuration, convenience function used throughout this module. With config, should we exec? So it takes should we exec, which is essentially a Boolean, but it's a union of these two types. RIO config, RIO runner. Okay. Perform a Docker or Nix re-execution. We have this re-execute function. And we just have a stanza for Nix and a stanza for Docker. With runner global. And whether we should upgrade. And that's it. Okay. So now I'm curious. Let's look at one of the execution functions. I just want to see what it calls to execute. Where's the here? If we want to use Docker, let's see, when m, which is maybe monadic when, get Nix shell, and possibly throw Docker within Nix invalid. Oh, okay. So if we're in the Docker stanza and it's trying to do something with the Nix shell, then that's an error because of the stuff we just talked about. You can't use Docker within Nix. Otherwise, get in container is going to be the return value is going to be assigned to in container, and if in container, then do is re-exec. If you check whether we're going to re-exec, and if we are re-execing, I don't know what inner is. So I guess we might throw an error, and then otherwise we call Docker run container and exit, which is presumably from a Docker. Okay, it's from stack.docker, so it's part of this code base, I guess. All right, so here's path, handy path information, a module stack path. We've got a path and a path parser, and I just want to see what they're doing with paths. Why are paths so important? But my guess is related to all the sandboxing stuff. Okay, so path is gonna take some text and do an RIO runner thing. Print out useful path information in a human readable format and support others later. Okay, so since this is printing out, that seems to support my conjecture that RIO runner is essentially IO of the empty type. Essentially a void function. All right, so print keys. Oh, it's going to be an RIO of env of parentheses. Is this RIO of runner? Oh, okay. Maybe, I don't know. Put string line and lift IO. So put string line is going to be IO, and then somehow we're lifting it to, I don't know what, but I guess to whatever this thing is, RIO of env parentheses. So maybe this isn't the same as IO, but it's RIO is the standard library thing. Runner is some sort of monad that's going to run stuff, like calls side effects. And then I don't know what this last thing is for, but I guess this means that like after the side effects, we're not returning anything. That's how I'm going to think about it. So fill path info has event config. Okay. Path parser. Path info tools dir snap root. I don't know what snap is, but global DB, local DB, snap DB. Okay. Pi compiler. What is pi? I'm not sure. And then a bunch of things that look like helper function, whether to use haddock. Here's some the paths of interest to a user. The first tuple string is used for description that the opt parse flag uses. I think opt parse is the thing we were looking at that is parsing flags. And the second string is the machine readable key. All right. So what directories do we have? Stack root option name, global config. No. Yeah, okay. Stack configuration file, project root. Yeah, so these are just paths in the build directory essentially. Okay. Here's Nix support. And I'm not going to look too closely at this, but we've got a big function. Let's look at what the big function is. Run shell and exit. Okay, so it's going to run, I guess, in a Nix shell and then exit. And then do we import anything Nixy? Stack config Nix. That looks like config. Stack types Nix. All right, so I'm just quickly glance at this run shell and exit, which is an RI config of void. Now I don't know what void is. I thought that parenthesis was basically void, but maybe it's not. All right, so here's an M shell file, config project root. I just want to see maybe occurrences of the string Nix, and if they appear in this long run shell and exit. Okay, so we do get a Nix Nix init file, and we have Nix compiler version. We import Nix compiler. Yeah, from config.nix. Okay. So config.nix is maybe going to tell us where our Nix stuff is. Like, I don't know if Stack is installing its own Nix sandbox, or if it assumes that you already have Nix installed. And okay, so it's running some stuff in a Nix shell. All right, here's Hoogle. So Hoogle is one of the coolest things about Haskell, in my opinion. Hoogle lets you like search for a function by type. So I need a function that's going to take some type and return. I'm going to take a list and I'll have it return just one element of it, right? So I can search for that, and a head is one thing that could do that, or a last. You need some way of picking out an element, take the first one, take the last one. Not a whole lot else you can do if you don't know how many things that might be in your list. But that's, the ability to search like that is super cool. So you might have like, anything else we should search for, like, you might want a function that takes a list of A and a list of B and produces, what can you do with an A and a B? I think without conditions on A, B, there's not a lot we can do. But we might take a list of A and maybe return a list of tuples of A, B pairs or something like that. And that's the zip function. Okay, so it's just like a super useful way to search for Haskell functions. Okay, so that's what Hoogle is as a like search engine, and this is some sort of Hoogle support for Stack. So it just says a wrapper around Hoogle. Type represent, but why? Why does Stack need? Like, I'm not sure Stack is going to search for functions in that manner on Hoogle. But I don't know. We've got some exception stuff. Hoogle command. It takes a list of strings and 3 bools, and it returns an RIO runner. Okay, and the list of strings are args, so arguments to Hoogle, I guess. The bools are set up, rebuild, and start server. And all right, ensure Hoogle in path. In path. Is there like a local Hoogle? Generate DB if needed. And run Hoogle. Okay. But why? Install Hoogle. You can install Hoogle. Oh, maybe this is Hoogle as instead of Hoogle, the web interface to the search engine. Maybe this is like local IDE Hoogle support, where like in your IDE you can send a request to Hoogle and get back some information, like as a tooltip or whatever. In which case, it might make sense for it to be in Stack, so that it, because I guess if Stack is doing things like sandboxing, it might then maybe that messes Hoogle up, unless there's some Hoogle aware Stack stuff. Maybe restrict min Hoogle version, mutable log, run Hoogle. So run Hoogle is going to take a path abs file, would be I guess an absolute path to a file, and a list of strings, and it's going to return REO and config. It takes a file, but what is the file? So run Hoogle. Oh, the file is Hoogle path, and the strings are Hoogle args. Okay. Check database exists. We're just going to get the Hoogle database path. Okay. So let's look up installing Hoogle. Install. No, I think this is looking up install on Hoogle. How to install Hoogle on Ubuntu. The Hoogle manual contains more details, including further details on search queries, how to install Hoogle as a command line application. That's what we want. All right, let's look at the Hoogle manual. Command line search flags. Okay. So flags, blah, blah, blah. Color, verbose, count, maximum number of results to print. All right, so you can, I guess, search Hoogle. I assume this goes out to the web. This is a Haskell, the search engine. Here's the online version, but maybe it doesn't go out to the web. The old manual is gradually being phased out. And maybe this is the new manual. Hoogle can be used in several ways, online, with the web interface, in IRC, using the Lambda bot plugin. Oh, cool. From Emacs by means of engine mode, or installed locally. Yeah, so maybe you can have your own Hoogle database, and maybe it's just, based on your code. The server at hoogle.haskell.org provides a version of Hoogle updated daily that searches all the packages available on Stackage. Okay. This document describes how to install and set up your own copy of Hoogle, which is useful if you want to search different packages, use the command line, or use Hoogle offline. Okay, so yeah, Hoogle does have offline mode, all right? So that's why these are Hoogle DB. And for reasons probably around wanting to support IDE features, there's Stack support for Hoogle, I guess. So here's IDE.hs. And it's functions for IDEs. We have an output stream, list packages command, list packages, and list all targets. Output stream. Why is output stream something exported by IDE? I guess that's my first question. So list packages will list the packages inside the current project. Okay. And presumably it's either going to look at stack files or look at Cabal files and do some stuff, print them out. So it's going to packages. It's got this view thing applied to build config L. I don't know what L is, to SMW project and BSCM wanted. I don't know what either of those things are, but we're going to map M output func stream of stirs. List package names. We've got this map thing. I don't know what the map is doing. My first thought was maybe we were passing it in to do some sort of like memoization in case we look up the packages frequently, but I don't see it being passed in. All right, so list targets is gonna it's more build config L and then SMW project. So I guess we want to know what build config L is. And we want to know what SMW project is. I'm not sure whether defined. Something the maybe prelude, maybe config, maybe probably build config. Let's look at this. Let's look at that build config now, I guess. Where was it? Types.config. All right. Was it something SMW? Build config L. Yeah, I guess it's not here. All right. Well, hopefully we'll find it later. Unless there's a... Unless I'm looking at the wrong file. Compiler, builder, named components. See if GitHub will let me search. Okay, so we do see some build config Ls. Okay, from stack types config. I was looking there. Were they not looking there? Here we go. Or maybe not. Where build config L is of type lens prime of n build config. Oh, it's the build config lens. Okay, I don't know what the SMW was. So SMW compiler. Oh, I think I missed something. Okay, source map. Source map wanted, maybe? So types.source map. Let's try this. Here's source map. So what is SM wanted? SM wanted, a source map with information on the wanted but not actual compiler. This is derived by parsing the stack.yaml file for packages, extra deps, their configuration, for example, flags and options, and parsing the snapshot it refers to. It does not include global packages or any information from the command line. And it's got an invariant. A package name appears in either SMW project or SMW deps, but not both. Okay, so SMW wanted is the compiler, the wanted compiler. What about deps? Okay. It's just the, I guess, SMW wanted for package name. I have a feeling that understanding this stuff is going to be important. So this is what stack/types. Let's take a look at what we've already opened, and then maybe dig around the types directory, I guess. All right, so here we are in coverage. I'm going to guess test coverage because Stack has the ability to run tests. Pretty coverage exception. Update tix file. I don't know what a tix file is. Move a tix file into a subdirectory of the HPC report directory. Look up tix. Generate code cov report from HPC data. Okay, some code coverage tool, I guess. Generate HPC report. Yeah, okay, so this is just code coverage stuff. I guess mostly calling out the existing libraries. So a build plan. This might be interesting. My main question is, do we have a graph? We're going to build a plan. Seems like we should have a DAG of some sort. I don't know, but we do have GADTs. Not here. Come on. There we go. All right, let's see. Exception, a build plan exception. And this is, yeah, I don't know. I don't have any sense at all, really, of Haskell style. But one thing I'm wondering is, it seems like it's common, at least in the, it seems like this repo puts the exceptions up front, which is good in a way. The impulse to do that, I think, makes a lot of sense. I definitely have that impulse, but as like a stranger reading the code, that makes it a little bit hard to understand what's going on in a package, because the first thing I need to do is like scroll past the exceptions and try to find out where the real code starts. Okay, so GPD packages, generic package descriptions, I guess is what GPD is for. And this we've got this GPD package deps, which takes an actual compiler, I guess, as opposed to a wanted compiler, a platform, some flag stuff, and package names. Remove source package default flags. Select package build plan. Find the set of flag names necessary to get the given generic package description to compile against the given build plan. Will only modify non-manual flags and will prefer default values for flags. Returns the plan, which produces the least number of dep errors. The least number. Is that what you want? Or maybe these, I don't know if these are errors or warnings, but like, do you want, if it produces any errors at all, I guess it's going to proceed as long as it's a minimum over other possible plans. All right, so what is it going to take? It takes a platform, an actual compiler, a map of package names to versions. So a thing that's you're going to be able to look up a package name and get a version, a generic package description, and it's going to return a map. Let's see. Okay, so the keys, I guess, are value names. Wait, no. Yeah. Okay. Okay. So there's two sets of parentheses here. So it's a map where keys are package names, and when you look up the package name, you get another map from flag names to whether the flag is populated, I guess. This is maybe in the C or C++ world, this map would basically be an int, right? So assuming this map is for telling you whether a flag was populated, that's equivalent to having like an int where one bit is the flag, and to know if it's populated, you just look at whether that bit is set. That's what we've been seeing. That's the sort of thing we've been seeing in when we've been looking at like the kernel networking code and stuff the last few times. I feel like we've been looking at a lot of C. At any rate, that seems like the sort of thing we're doing here. And then the other thing we're returning is dep errors on the right. Okay, so select package build plan, and okay, with the compiler, platform compiler pool and GPD. That's the generic package description. And what is pool? Pool is the map from package names to versions. And what do we do? Okay, so select plan is going to fold over some stuff with fewer errors. Okay. There are fewer errors of P1 and P2 means we're going to, if n errors of P1 is 0, then we're going to give P1. If n errors of P1 is less than or equal to n errors of P2, we're going to return P1. Otherwise, we're going to return P2. All right, and n errors is equal to map.size composed with the second element of like a tuple. All right, but what have we done? Map.size goes with second. And we're calling it on P1 and P2. And P1 and P2 are, what are we folding over? So select plan is going to take a non-empty a dep errors and return a dep errors. But, okay, so fold fewer errors. And what are we applying it to? We must be applying it to, now, first of all, what do we do with the compiler? Are we at the end of the function? No, we're not. Okay. No. Okay. That makes more sense. Let me see where compilers is, just to make sure I'm not at the end of this function. So Haskell has significant white space. And I think that's tripped me up before. Yeah, okay, so compiler gets used down here. Okay, so this is just getting the plan with fewer errors up here. I'll keep compiler highlighted, I guess, just to orient myself. And then we're going to do this limit search space, non-empty A to non-empty A, and avoid exponential complexity in flag combinations, making us sad pandas. See this issue. Does this mean that we started with exponential complexity and then realized there was a problem? Let's look at this issue. Stacking it runs for hours when building git annex. It would seem that git annex has 24 different flag options, which are all being tested by stack. Do the 24. Is this number, what is this? That's thousands, hundred thousands, millions, 16 million, around 17 million, which obviously takes a long time to test. I'll just hard code an upper limit, like 100 flag combinations to test before giving up. Okay, so maybe I was wrong about flags. Maybe these are not bit flags. Maybe these are command line options, command line flags. Map flag name. Yeah, let's assume for now that they're command line flags. How many flags does git annex have? 24 different flags options. Let's look up git the man page for git annex. And I just want an order of magnitude check on the command line flags. Repository setup commands. Yeah, I guess so. Yeah, so these are not well, it's still kind of like a Boolean, but you can't use like an int, I guess, because the meaning of if it's command line flags, the meaning of the programs have different command line flags. So it's not like they all have the same types of flags that you can set. I guess that's why we have a map and not something like an int. Okay, all right, so we're going to limit the search space with this function where max flag combinations is 128. All right. And then make plan. Wait, where are we now? So how many spaces do we have here? None? Are we at the very beginning of the line? And then here, make plan, we're indented. Okay, so this is like a function, I guess, defined inside of select package build. All right. So make plan is going to take a list of tuples of flag names and bools, basically, I guess, whether that flag is set. And it's going to return this map thing. Basically the same as the return value of the function as a whole, I guess. And make plan of flags is going to check package build plan with the platform compiler and pool, and the flags and the generic package description. And then flag combinations is going to take a non-empty, I guess, list of flag name bool combinations and call map m, which I think is like a monadic map on get options. Okay. But somehow it's getting options. So Dan and Jay says, they just came across my channel and keep the types of live stream coming. Hey, thanks. Thanks, Dan and Jay. And they say I deserve more subs. And there aren't many channels that dive deep into source code. I appreciate that. More subs is always good. For a while, it seemed like more subs is good. I guess I'd like to grow at the right pace as opposed to as quickly as possible, I guess. That way we can keep our flavor and build up over time. That was my goal anyway. It kind of from my perspective, it kind of took off much quicker than I was expecting, which was nice, which is really nice. But also more pressure. So yeah, that's really nice. I'm glad if you know people who like this sort of thing, or you think that would like this sort of thing, spread the word, I guess. Cool. So all right. So then check package deps. is going to be this function that we call, okay, so check package build plan and check package depth. I think these are the functions we called here in select package build plan. Did we call them? I feel like we did. Yeah, okay, so here's check package build plan and maybe not check package depths, but maybe that's called here or something. Okay, so check package build plan is going to check whether the given set of flags, a package's dependency constraints can be satisfied against the given build plan or pool of packages. But what I want to know is how do we check that? How do we check this? Maybe I'll look at the body in a second. It's very short, but just for the sake of making a guess, seems like we're probably just going to ask GHC to figure that out for us. But we'll see. So, this is map singleton package flags errors, where this stuff package is GDP package name, GPD package name, which we get from the GPD object, and errors and constraints, GPT package depths. Yeah, maybe this is the place to be. Check package depths, which is different from GPD package depths. All right, let's look at check package depths. Check that the given package dependencies can be satisfied by the given set of packages. Will fail if a package is either missing or has a version outside of the version range. All right, combined dep error. So this seems like error handling or go. Okay, from package name, version name. We're gonna look up stuff. Seems like all we're doing is looking stuff up. So does this mean that all the work is, this might mean that all of the work is in a sense already done, but wherever builds up the maps. I'm not sure. I was kind of expecting to see like some logic that figures out all this stuff, but it seems like doing a bunch of mapping stuff and juggling errors around. Check bundle build plan. Okay, so here's a platform compiler pool, select package build plan, check package build plan, compare build plan check, show build plan check, check snap build plan. What is snap? Check a set of generic package descriptions and a set of flags against the snapshot against the given snapshot. Returns how well the snapshot satisfies the dependencies of the package. All right. Like the best snapshot. Are we just doing error counting again? There's something about errors. See errors, compiler errors. Snap packages is going to be a union of some stuff, like depth version and global version. Okay, so if there are no errors, then the build plan check is okay. If we have some errors, then I guess build plan check partial with errors. Map.null, see errors. I don't know what's going on, but we're checking if there are errors, and somehow that's going to presumably inform us which snapshots give us the best build stuff. Okay. Select best snapshot, show items, show package flags. Yeah, I don't know. So we're gonna proceed along and close this out. My gut is telling me that the logic I'm looking for must be in another file. But maybe it's there and I'm not seeing it because I don't have the right mindset or whatever. Okay, so here's build.hs. Okay, and Dan and Jay is asking, do I have any tips on how to understand source code better? Last, I tried understanding Redis. Wait, can I pop this out? Let me try to pop this out. Does this work? I'm just gonna put, I'll put this here because what happens is after the live stream, while live streaming, I also record a higher definition version and then I upload that. And so when I do that, what I used to do is disable the live stream recording, which is the lower resolution thing. And then it seems like once you do that, YouTube like deletes your chat history. So I have to figure out a way to upload the higher quality version without losing the information from the chat. So I'll just try popping out this chat window and showing it on screen. If that's okay with everyone, I assume that's fine. If you're chatting, then I think the chat is public to anyone who watches if I had left that video up or whatever. Okay, so they're asking. All right, so last time I tried to understand Redis from source code, it took me 3 days to understand the logic, but I still felt like I lost. Yeah, that's normal. So I think one thing, yeah, it's a great book. Oh, wait, okay, so I got to make this, hang on now. Here's what I got to do. I got to make this stay on top. Is that something I can do? Whoa. Let's try this again. I don't, I'll just move this in for now and I'll figure out how to keep it on top later. Well, no. Yeah, no, that's normal. If it takes you like less than 3 days to understand Redis, then I would question whether you actually understand what's going on. And source code is hard, and what we're doing in this channel is just like practicing, but you'll see me like go back into repositories after taking a break, and that's intentional, because for something complicated, like if you're going to become a Redis developer, like working on Redis, it would realistically maybe take you at least like 6 months, like maybe a year before you really had a sense of like the whole repository, I would guess. I'm not sure how big Redis is. I think it's probably big. But, and then, for a big enough, complicated enough repository, there's typically nobody who really understands everything that's going on. So like one thing you see me do in these videos is just declare that I'm confused and don't know what's going on, and then just proceed anyway. Because if you don't do that and you insist on understanding everything, then you're kind of doing a depth first search, and there's just too much depth to make progress. Why don't I use an OBS plugin for comment selection? I don't know. I mean, this is a panel on the thing I'm showing on screen is a panel from OBS. There are probably are plugins. I should explore the OBS ecosystem more. I've tried to install at least one plugin, and it basically just refused to work. so I gave up. But yeah, I'll have some solution for it for sure, and I'll make sure that it stays on top. And 3 days to just understand the basic logics. Okay, well, I don't think that's unusual. And I guess like it depends on what the logic was. But yeah, so tips for understanding. One is just to like read a lot of it. I think so. I really started. Like just jumping into random source code at Google, and it was part of it was just driven by the fact that there's so much history there, right? And I was just curious how things worked. So that's how I kind of developed this particular habit. But if you just read source code like a normal person, not like some sort of like whatever I'm doing, then you do eventually get a feel for it. And a lot of it is like design. So for something like Redis, I think Redis is like is it ultimately like a key value store? There's a lot you need to know. So like it could have been hard to understand because it was like performance optimized. It could be hard to understand because it was like trying to be heavily generic. There's all sorts of things but my advice is just to persist and allow yourself to be confused and like be aware of when you don't understand what's going on. I think a lot of people like kids, kids especially will like say that they understand something when really they're confused, and so just knowing what you don't know, I think, goes a long way. Um, but yeah, I mean that's mainly my tip. You got to practice. So there's this book. Let's see if I can find it. The book called How to Read a Book. Let's see. Yeah, from 1940, and it's kind of a ridiculous title. Um, but it has this like multi-pass system, if I remember it correctly. So this is for reading a nonfiction book in order to gain an understanding. He claims that three distinct approaches or readings must all be made in order to get the most possible out of a book, but that performing these three levels of readings does not necessarily mean reading the book three times, as the experienced reader will be able to do all three in the course of reading the book just once. And he calls them structural, interpretive, and critical. Um, the third analytic reading. So, so my take on something like this is I think that whatever in 1940, Adler had more or less the right approach. I think he was a philosopher, right? So he's a philosopher. So he's reading philosophy. Reading philosophy is different from reading like a math textbook or a computer science textbook or a paper or code, because that stuff is more complicated. But I think his idea of like doing different things as you're reading, and at least as I remember the book, there were like multiple passes through the book, and so that's kind of my approach. Instead of trying to like really squeeze the juice out of one pass through something, I typically go in with the mindset that I'm going to make several passes, um, and if I look at something and I'm just totally bewildered, then what I think to myself is like, okay, well, that will require more passes than other things, and then hopefully I'm not doing it on a deadline. But if there's no deadline, then like it doesn't really matter, um, like how quickly I proceed. And so like you might read through something and then like a week later check it out, or like a month later check it out. So that sort of thing I think is not really talked about when we're taught how to study or how to read. At least I don't remember it being talked about. But I found it in practice is super effective. And now I've clobbered this window again. Let me see if I can find it. This is not any framework. But yeah, it's good. uh, so Saurav, what do you mean when you say that this is not any framework? And since Dan and Jay thinks that's a funny name for a book, which I think it is, there's like a there's a there's like a satire. Maybe it's on the Wikipedia page. There's a satire called like How to Read a Page. Let's see if we can find it. Maybe just an image search. Oh, no. Let's add. No, I'm not finding it. Maybe DuckDuckGo/Bing is how to read a page. Yeah. I want an image though, not video. Professor I.A. Richards wrote a serious treatise entitled How to Read a Page. And there's also called a book called How to Read Two Books. Um, at any rate, since I'm not finding it, I don't think this is especially entertaining content, but I'll do one last attempt to see if I can find it by including the author's name. Yeah, this thing. I remember there being a funny image. Can I look at this file? I don't know. All right. Or maybe how to read two books. Yeah, here we go. This is the thing I was thinking of. Um, and then this cartoon says, "Now we are getting to the point where the reader is about to think." This is silliness. Okay. All right. Need to take a look at chat. Okay. Well, I'll put chat back offline because it keeps getting clobbered. But I'll find some solution for how to do chat properly. Wait, what? Don't do that, OBS. All right, that's fine. Okay, so back to Stack. Okay, did we really close out all the other files? No, we did not. Let's go to this. Okay, so here's build. Right, we've got distribution stuff. I don't know what that is, but JSON up here, data list. Compiler stuff. All right, Cabal. All right, we've got some Cabal stuff here. Query exception. This is looking promising. So build. Okay, the build function is going to take a has env config of env, I guess, and an optional set maybe like a set theory set, like a collection of absolute file paths to IO, which is a callback after discovering all local files. Okay, so this is some callback. And then RIO env build. If a build lock is passed, there is an important contract here. That lock must protect the snapshot, and it must be safe to unlock it if there are no further modifications to the snapshot to be performed by this build. Okay, so some warning about locking. All right, so build on mset local files is we're gonna have do notation, since I guess we're in whatever this monad is. MCP, I don't know. Config modified code page, GHC version, fix code page, some stuff with GHC version, and config source map, check library dependencies. All right. And do we call GHC or Cabal? We have GHC version stuff. What about Cabal? We have Cabal version. We can check the Cabal version. Local exes, maybe local executables. Exe package name package. All right. Warn about split obj. Okay. So there's, I guess, some split objs flag. Warning. Note that this feature is experimental and its behavior may be changed and improved. You will need to clean your work doors before using. Okay, I guess maybe split objs is a stack thing. Base config stuff with some snapshot in a local DB and a snapshot DB. Load package, provide a function for loading package information from the package index. So we're going to pull stuff from the package index. We can query build info, query information of the build, and print the result to standard out. So what can we query? I guess env maybe just means it takes place in an environment, maybe a Nix environment. I don't know. And it's got a list of strings, which are selectors. Or a list of text, I guess. Not technically the string type, but fundamentally they are strings conceptually. And then we're just gonna do a bunch of map lookup stuff. Check. Yeah, so I really feel like what's I should find where the databases are built up, and then maybe the map lookups are all about essentially querying the databases. So here's concurrent execute. This I'm just interested in for its own purposes, just to know about concurrency in Haskell, unrelated to the build system in particular. So concurrent execution with dependencies. I don't know what with dependencies means in this context. Types, currently hard-coded for needs of stack, but could generalize easily. Okay. All right, control concurrent.stm, execute exception, and we've got action types, build final, run tests, run benchmarks, and action IDs. This is a common pattern. I don't know if this is, yeah. Anyway, we've got actions and things we can do with actions. Concurrency is whether we've allowed or disallowed concurrency. Execute state, actions, exceptions, inaction, completed, or keep going. There's some sort of like state, machine states. Run actions. It's going to take an int, which is the number of threads. Bool, whether to keep going after one task has failed. A list of actions. And tvar, which is maybe that's similar to mvar. We'll look up tvar in a second. So tvar of int and tvar set action ID to IO parentheses, which is progress updated. And it's going to return an IO, maybe with, I guess, with a list of some exceptions. The run actions, threads, keep going, action 0 with progress do execute state on it's, I don't know if these are called combinators, but whatever these things are, like infix functions in Haskell. We're doing stuff with the new tvars. And pure keep going. I don't know what pure does. Maybe it unmonadifies something. Async with progress. S completed S in action S. If threads is less than or equal to 1, then run actions prime on S, ES. What is ES? Oh, execute state. But we're also using execute state down here. And we define it here. But how does it get here? Oh, we've defined it here, and then this is a new line, I guess, because I was missing this underscore. So whatever this return value is, I guess we're going to ignore it. So we're going to define execute state, I guess, through whatever this is. And then async, we're going to like async call with progress, this ES completed, ES in action. So this is maybe the progress update. We've got the state. I guess this is maybe the progress callback sort of thing. And then we're going to check whether we have less than one thread, less than or equal to one thread, in which case we call run actions prime on ES. So on the execute state. Otherwise, we're going to replicate concurrently underscore. Trying to highlight this underscore. There we go. Threads run action prime. Yes. Okay. Not really sure. Well, we would need to look at the definition of run action and related stuff if we really wanted to understand what's going on. But fundamentally, we're getting the execution state, I guess, updating progress somehow. And then if we have more than one thread, we're going to execute concurrently. The sort actions are those that can't be run concurrently or at the end. I guess they can't be run concurrently because we've got to sort over everything. And so all of the other work has to be done ahead of time, I suppose. And then run actions prime execute state. It's going to be a loop. Okay, so we're just essentially an infinite loop, and we're looking for things like break on errors with actions, inner do. Loop is join atomically, break on error. Okay. So some execution loop thing, but in Haskell, idiomatically Haskell, I guess, is how I'm going to think about this. But I don't see where concurrency is. Maybe I need to look at the folder. Okay. Oh, concurrency is just this like essentially like a bool about whether it's allowed or disallowed. Okay. All right, so here's HTTP. We have stack client, which I'm going to guess is just a client to stackage. Wrapper functions for network.http.simple. a network.http.client. Oh, okay. So I guess it's just an HTTP client, but modified for stack usage. How are we on time? 140. Getting along. Okay, so this is just what's the word? Convenient. I guess a convenience wrapper functions for an HTTP client. So here's system process pager. Run external pagers. Huh. Oh, things like less and more. Why? Run a pager providing a function that provides the pager's input. Okay, so I guess we can page through some stuff in stack. Here's the applicative directory. And let's look at complicated. Should we look at builder? Extra? I guess so. So complicated. Simple interface to complicated program arguments. This is a fork of the opt parse simple package that has some workarounds. Maybe by complicated arguments, it means like nested or interacting command line arguments. Complicated options, version, maybe string, blah, blah, blah. Add command. Is it defining add command? Commands use add command with a lowercase a, but this one has an uppercase a. All right, I think that this is options parsing stuff, and I'm going to ignore it. So here's builder extra. Are these just extra arguments? Type representing exceptions thrown by functions. Stuff about enabling flags. Okay, I'm going to guess this is also option parsing stuff, which would make sense since it's in options/applicative. Okay, now what did I say that we need to look at? I think types, but not in source/main apparently. Did we look at all of concurrent? We just have execute. Is that what we looked at? Actually, yeah, I think that's what we looked at. So where's the logic? I don't think it's in Unix. Is it in data, path, stack? I think it's maybe in stack, types, or storage. GHC package. I think ls is. Package dump, package file. Prelude runner, sdist. I'm just going to open a bunch of stuff I didn't open before, and see what I can see. Types, build.hs. Did we look at compiler build, dependency, GHC package ID, named component, nix package, resolver, source map, storage, and version. And then I'm going to search just for the string graph. Let graph equal map keys package name. Now we have print graph and prune graph and dot.hs. I don't know what dot is, but let's look at that. Is this the right one? Yeah, let's look at dot.hs. We have .ops.payload, right? And distribution stuff, ASON, RIO process. Here's more exception stuff. Options record for stack dot. What is stack dot? Thank you, Cole. So Cole says, found this channel last night. This is some god tier content. Thanks. I really appreciate that. That's very kind. Here's the dot command. Okay, so graph is. So I guess it's gonna print out. So graph is a tool. We've seen it so many times now. Just coming up in like other tools are using GraphViz, and I've always thought of it as like a vector drawing program. But I guess one part of the idea is that you can uh, programmatically generate a GraphViz file, and GraphViz will render it for you. So let's just see if we can look at some GraphViz. What's it called? Gallery? Is there a gallery? Yeah, there's a gallery. Hey, look at that. This should be where they show off what GraphViz can do, just so that we have an appreciation. What is this? This looks like these are not graphs, are they? What? Wow. I don't know what these words are. Ammonian, AG ammonium. Let's just pick one that looks densely populated. So we can see in the PDF for this matrix for coordinates, and it rendered in 3.41 seconds from AT&T Labs. Let's see if I can just look up the string Monian. Let's see what happens. I don't know. AG. I don't know what AG is or what AG Monian is. See the gallery of large graphs. Okay, so Ninja build system, parsing tree, polygons, neural network. Let's look at a neural network. Wait, is this the gallery? Here's the color wheel. Okay, so, graphs. I guess it's fast. All right. Graph visualization, visualizations of matrices from the University of Florida collection. Okay, complex relations, sparse matrix collection. I guess these are collection. This is like a whole thing. A widely used set of sparse matrix benchmarks collected from a wide range of applications. So I guess these people want to understand maybe like the performance characteristics of sparse linear algebra or something like that, which is used in all sorts of applied fields like applied math and engineering. So I guess they collect sparse matrices and they also collect drawings of them via GraphViz. At any rate, what .hs is doing is drawing graphs. But what graphs is it drawing? I guess dependency graphs. And where is it getting the dependencies from? So we have this list dependency function. All right. That's list dep.ops, blah, blah, blah. But where are we getting it? Create prune dependency graph. This is the function I want. Can I find it? I create the dependency graph and also prune. It does prune it as specified in the dot options. Returns a set of local names and a map from package names to dependencies. So what are we doing? All right, so we're going to have this debug statement. We're going to create the dependency graph. We're just going to call it create dependency graph. And then I guess we're going to prune it separately. So what does create dependency graph do? Use source map L. Load local package in some for loop. I'm wondering if source map is the place to be. Okay, wait, I have a dp ghc package ID global dump. Okay, global dump. All right. So it seems like this global dump stuff and the package DBs are relevant to like how we're actually looking at package data, but also this source map thing. Where was that? Types source map. Let's go there. Maybe here. Source map. Okay, a source map maps a package name to how it should be built, including source code, flags, options, etc. This module contains various stages of source map construction. See the build overview MD doc for details on these stages. I will see that doc. But I don't know how to get to it. So let's try opening a new tab. Maybe Wasn't there a doc folder? Oh, but not in source. Build overview. Was that where I was supposed to be looking? Build overview. Yeah. Okay. Yeah. All right. I just want to see if there's a picture. I don't think there's a picture, but maybe we can at least look at let's look at the rendered doc. Wait, this is just the entry point. Okay, so we've got some terminology inputs. If we're going to find the stack.yaml file, I guess. Wanted compiler dependencies and project packages using, I guess, resolver. Load up the snapshot indicated by the resolver. Look at the compiler flag, extra deps. Get the actual compiler. Use the wanted compiler and various other stack config values to find the actual compiler. Once we have it, list all the packages available in its database and resolve targets. Take the CLI arguments for targets as raw text values and turn them into actual targets. Do a basic parse on the values into one of the following: package name, blah, blah, blah. And apply the CLI flags. Okay, determine snapshot hash, determine actual target components. So maybe all of the package database stuff is just being handled by GHC, possibly. At any rate, here is sourcemap.hs. We've got common package, common settings for both dependency and project package. We have dep package, an overview of a dependency package specified in stack.yaml. And we've got common package name, location, whether it's hidden, DP from snapshot. I guess we can get the dependency from a snapshot. And project package has similar stuff. And we have a global package. A view of a package installed in the global package database also could include a marker for a replaced global package. All right. And then here's the wanted compiler stuff we saw. Here's the SM actual, stuff about project type, SM targets, and source map hash, which is source map hash of SHA-256, a unique hash for the immutable portions of a source map. And then something about relative directories. All right, cool. We're getting closer, I think, to what I wanted to see. And then distribution.package description. But where are we getting there doesn't seem to be like any GHC imports, right? Okay. All right. Well, so let's look at resolver. We've got some JSON stuff, applicative option parsing, pantry, whatever pantry is, seems to be somehow related to JSON, and stack prelude. You might want to look at the stack prelude. So exception stuff at the beginning, read abstract resolver, display abstract resolver from JSON, and snapshots. And nothing else. This is just the types for the resolver. So maybe let's look at the actual resolver. Not here. Type storage. Build. Source installed, execute. It's just installed. Get installed. Returns a new installed map and all the locally registered packages. Okay, so here we're going to do some, so installed.hs is going to do some package database stuff, which is, okay, this is awesome. this is maybe the sort of thing I was looking for. So it's going to load package databases and add in the executables that are installed, making sure to only trust a listed installation under the right circumstances. See below. Okay. And then exe snap, maybe execution snapshot. And then local database, load database says outputs both the modified installed map and the set of all installed packages in this database. Okay, and then what do we import? Package dump, constants, build cache, source map, GHC package ID. All right. Let's just move along and try to close stuff. Package.hs. What is this distribution.system? Distributions. So these are distributions of the Glasgow Haskell compiler, I guess. And there's also some Nix stuff. Cool. Is this where I was? Package.hs? I don't think it was, but I guess it's where it will be. So let's look at package.hs. We have things like installed, install map. These are things that are exported, I guess. We've got a memoized with function, which will presumably do some memoization. Yeah, maybe this is where I was. So we have a bunch of distribution stuff, some stack stuff. Exceptions are at the top. And then we have a package intro. This is looking promising. A bunch of package metadata, default flags, build type, setup deps, package ident, which is I guess an identifier, install map, get package opts, and some package build config, which is like essentially a struct. Package source, show package source. Okay, let's look at package source. Where the package's source is located, local directory or package index. Okay, so it's either in a local directory or it's in a package index. And then a local package is kind of like a struct. LP package, LP components, dirty files. Nothing is equal to not dirty, just is equal to dirty. Note that the set may be empty if we force the build to treat packages as dirty. So dirty, presumably in the sense of like it's been modified. And we have this example of memoization. Memoized with an end config, I guess environment config. Okay. Now let's look at memoized with. It's going to be equal to memoized with, unmemoized with, and deriving. Oh, I think this is just telling us that memoized with is deriving some stuff. And here's memoize ref with monad IOM. Okay. And it's got some rough stuff. Oh, we're going to look up tvar. We'll look up tvar at the end of this file. All right. .cabal module. Maybe get the module name from the .cabal descriptor. .cabal main, .cabal main. Okay. This is starting to look like more like the code where we're going to get stuff from the file using things like cabal and GHC. So let's look up Haskell tvar. Shared memory locations that support atomic memory transaction. Oh, okay. So like a transaction var. I think there's mvar2, but maybe that doesn't support transactions. mvar t is a mutable location that is either empty or contains a value of type t. It has two fundamental operations. You can put it and you can take it, which empties an mvar if it is full and blocks upwards. So once you take it, it's gone. Okay. And then I think the difference is transaction, but we'll look up mvar versus tvar versus mvar Haskell. TVARs are safer but slower. MVARs can deadlock, but are much, much more efficient. Okay. So TVAR is a mutable reference to within STM, representing a general shared state. Okay, so TVARs have better guarantees, but those guarantees cost, you got to spend some cycles, I guess, to get them. Here's dependency under types. Okay, so we have a dependency value, dep type, and some semi-group stuff. This looks as library, but whatever this thing is called, applied to like default, it's just going to be as library, but as build tool, like applied to, I guess, X, is going to give you back X or something like that. Those are like the semi-group operations. Actually, let's look up what a Haskell semi-group is. Okay, so we've got this associative function. I don't know how to pronounce this. Does this tell us infix 6, infix R6? Okay, whatever this operation is called, it's associative that lets you combine any two values of a type A into one. So A diamond B altogether diamond C this is just associativity. And it's just an associative binary operation, which is I think what a semigroup is in real life too. Let's just double check. Like I guess you don't need an identity or anything. It's just a set with a binary operation that satisfies the associativity property. It's an associative magma. I guess I didn't remember that magmas could be non-associative. And a magma is just a set M with an operation that sends any two elements back into another element of the set, right? The set and the operation must satisfy the following requirement, known as the magma or closure axiom. For all A and B and M, the result of the operation A times B is also an M. Right? I guess they decided it wasn't formal enough to say this is a binary operation. This is just what it means to be binary, right? You have two things in the set, and you get a thing back in the set. Okay. All right, so here's compiler. Why did we do that? I don't remember, but there is some semigroup, and it has magma is just any binary operation, and then I guess semigroup is you have to also be associative. It's a pretty weak condition, I think. So compiler build. Well, maybe it's strong. I mean, I guess in code it's strong. I guess there are probably ways to rack associativity pretty easily if you wanted to. All right, so compiler build. There's not much here. These are just the types, though, I think, right? But what types do we have? Compiler build name, build suffix, and compiler build. Parse compiler build from a string. Okay. Those look pretty harmless. So here's the types compiler.hs. We have things like actual compiler, which compiler, compiler repository, default compiler. So this is going to do like management of our compilers. And I'm pretty confident that that's what it's doing. So I'm going to just close it out. And unpack, what is unpack going to do? We've got a path. Unpack packages intended to work for the command line command. For all end has pantry containing blah, 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 blah. Maybe raw snapshot when looking at by name. Unpack packages, m snapshot, dest input, do. A bunch of error stuff, partition ethers, for m. We're kind of like, we have less descriptive variable names and more like looks1, looks2, errors1, errors2 already unpacked. So I'm not going to, I guess, try to deeply understand this function, but it's going to somehow unpack packages. I don't know if that means unpackagify them or just get them out of the snapshot or something. So I guess to local snapshot. It's going to take a raw snapshot and a package name. It's going to do some map lookup stuff, check whether it appears in the snapshot, and do some parsing of the package name, and get the package identifier revision, and return t.packS. And then to local snapshot, I guess, is going to do the opposite. Or no. These are similar functions. To loc no snapshot versus to loc snapshot. Okay. What was I going to look up? I'm going to look up for all. I forget how for all functions in Haskell. Explicit universal quantification. Okay, Haskell type signatures are implicitly quantified. When the language option explicit for all is used, the keyword for all allows us to say exactly what this means. For example, G is a function from B to itself, means that G for all B, B goes to itself. They are treated identically, except that the latter might bring type variables into scope. See lexically scoped type variables. As well as in type signatures, you can also use an explicit for all in an instance declaration. Instance for all A, EQ of A. Maybe if this means that A implements equality, then EQ of list A, where note that the use of for all S in instance declarations is somewhat restricted in comparison to other types. If the unused for all's flag is enabled, a warning will be emitted when you write a type variable in an explicit for all statement that is otherwise unused. For example, for all A, B, I guess we're not quantifying over A, so that would issue a warning. Yep. Okay. I still don't have a sense of, why you would want to do it, but here's an example. For all AB, and then I guess the dot ends the quantification, the statement. We have a function. So foob is going to take a function from B to itself and a B and a function from A to B. And it is going to return a function that takes a maybe A and returns a B. Okay. Foob post process on nothing, on just mval, post process val B. This code doesn't compile, it requires an extension. There are 3 different common use cases for all. Each has its own extension. Scope type variables, rank n types. And what's the third one? Existential quantification. Okay. So this is all fascinating, but maybe this is not the forum to explore all 3 different types of uses. But it seems like maybe in here I'm mainly seeing it in it might just be explicit for all, where we could have gotten away with non-explicit for all, maybe. Okay, so here's sdist. Create a source distribution tarball. All right. So this is just going to bundle up some source code. Codec archive tar. I don't know why we need to do this. Given a path to a local package, create its source distribution tarball. While this yields a file path, the name of the tarball, this tarball is not written to the disk and instead yielded as a lazy byte string. All right, so it's giving us a file path, but it's not actually on the disk. But I guess maybe it will be on the disk if you lazily ask it to be. And we've got some Cabal stuff. Lift IO, IORef, snapshot, dump packages. Okay, so this is getting down in the implementations. So we've got some snapshots, dump stuff. Basically a bunch of packages, and we know which ones are installed. And we've got some package databases and pretty info. I guess we're going to print some stuff as we're operating on them and somehow tar them up. We're going to loop below and eventually find the Cabal file. When we do, we'll upload this reference. If the MPVP bounds value indicates that we should be uploading a Cabal file revision. So maybe this is for uploading your package, your distribution. Package file. Resolve file or warn. Package desk modules and files. I feel like package a module which exports all package level file gathering logic. I think I do want to look at this. Package level file gathering logic. So this is going to find the files for a package, right? We've got library mods, dot cabal files, warnings, and dot is different from the dot graphviz thing. This is dot as in the sense that the file extension, dot cabal. Okay, so lib component, fold tuples, exe component, cexe, t.pack, cabal.unqual, component name, exe name. Resolve glob files, resolve globbing of files. For example, data files to absolute paths. So we're going to, I guess, unglob some stuff. If you ask for star, then we're going to explode name. Else map pure, resolve file on warn name. Okay. Here's package dump. Where are we, by the way? Source /stack/package dump. Okay. Some more exception stuff. GHC package dump. Call GHC package dump with appropriate flags and stream to the given sink for a single database. Okay, so here's the code, I guess, finally, that ultimately calls GHC and has it handle packages. And prune depths. Prune a list of possible packages down to those whose dependencies are met. So how do we, how do we know that they're met? Loop, found IDs, used names, found ID, found items, DPs, partition ethers. So I guess we're gonna loop over and just check some stuff, whether they're in the maps. I thought maybe we were just gonna ask GHC if the dependencies were met, but this seems like stack logic. That like stack is gonna figure out how they're met by looking through things that it knows about. Sync matching, find the package IDs, matching the given constraints with all dependencies installed. Right, conduit dump package. Convert a stream of bytes into a stream of dump packages. So maybe this is where conduit appears, is that it's just like an optimized version of some stuff we're already doing, like writing packages to disk or to network or whatever we're doing. So here's package.hs. I feel like I just look at this. Read.buildinfo. Okay. So this is going to read some, whatever a .buildinfo file is. Resolve package. Resolve a parsed Cabal file into a package, which contains all of the info needed for stack to build the package given the current configuration. Package from, so ultimately we're calling package from package description, which is this function. And it's just gonna like populate this package. I've been calling it a struct because we've seen so many structs the past, maybe just yesterday, I don't know, recently. But whatever this is in Haskell, this data type thing, it's like a record, I think. Maybe it is literally a record. It's certainly record-like. And we're calling out to Cabal for some stuff. Unqual component name, unqual component name, etc. Package config GHC options. So it seems like we're using Cabal and GHC kind of as you would expect. And we've got a bunch of these kind of long logic-y functions where we that are doing Haskell-y things, doing like idiomatically Haskell things. Like, I don't know if we're doing like folding here, but we see a lot of folding. We see a lot of whatever pure is. Maybe I'll look up whatever pure does. Is it a keyword or a function? Let's call it a keyword. Pure. A pure, well, I know what a pure function is. What is the purpose of pure and applicative? Maybe it's part of applicative. Blah, blah. The pure function solves problems that might occur here. E.g., wanting to supply a function that is not residing in the applicative. It accepts a function that is not currently residing in the applicative and lifts it into the applicative. Okay, so it like lifts it into a different context. So you can use it in applicative. Okay. So maybe it means that the thing pure is called on is a pure function, and you want it to become applicativified. You want to applicify it. Okay, so I'm getting a better sense of how this works, which is not the same as saying that I understand how it works. So like, so maybe just go back to Dan and Jay's point. We're to understand the logic, but I still feel lost. I'm not understanding the logic of stack yet. Like, if you ask me what stack would do, like if you ask me to execute stack test on some repository that you checked out, I wouldn't be able to describe what it was doing. And if I wanted to know what like stack test or stack build or whatever those functions are called, if I wanted to know what those were doing, I could find the files at this point. But if I had just jumped into those files and tried to understand what the logic was, I wouldn't really get anywhere, because like every word I read, it'd be the name of some type that I didn't have context for. So so I'm getting, so I say that to try to convey that like in this path through the stack repo, I'm not. I am getting something out of it. I'm getting something important out of it, which is kind of like a lay of the land, a sense of how the stack authors think, what they think are important constraints, and those sorts of things. And then for something like understanding how the logic works, for something really complicated, you might like use a debugger to actually see like where things are going. But at least now, if you wanted to know how a particular function looked or worked, I think you'd be in a better place to read it because you understand more of what the words. Or when I say you, I mean me. Hopefully, also other people who are watching. But you'd understand more of what the words mean. Like, hopefully that makes sense. I guess I'll stop. I don't want to ramble indefinitely about that, but that's that. Okay, so here's ls.hs. I'm just curious what ls is. Exceptions. Maybe stack.ls is. Maybe ls is a command that works like list ls in the Unix environment. Can you see the commands? ls command. Okay. This different types of information. Okay. So this is for listing stuff. I'll ignore it. It's just going to iterate over some stuff. All right. GHC package. This is going to be get the global package database. Okay. Run the GHC package executable. This is so GHC package must be like a utility, probably from the GHC main repo for handling packages. Yeah, to handle packages used both internally by other tools and by GHC users. This means that it contains many commands that are often not needed by an average user. Okay, so we're ultimately calling out a lot, I bet, to GHC package and Cabal, and we've seen some of those calls. And then I guess the layer that Stack is adding, I think, as I said at the beginning, is like UI convenience, niceness, making the Haskell ecosystem more similar to other programming ecosystems that are popular. At any rate, in GHC package.hs, we can create a database which creates a package database in the given directory if it doesn't exist. Okay, yeah. So I'm glad I found this stuff. But now that I know where it is, it's in stack/GHC package. I don't think this is super important to understand exactly how all the calls work. All right, and then storage is project, user, and util. Let's just look at project. More pantry stuff. We have SQLite. Let's look up pantry. What is it? Hackage? Pantry. Content addressable package management. Haskell package management. What? So here we get Michael Snoyman again. Maybe we're calling out the pantry a lot. Content addressable Haskell package management, providing for secure reproducible acquisitions of Haskell package contents and metadata. What is Pantry? A Haskell library, storage specification, and network protocol. Intended for content addressable storage, allows non-centralized package storage, primarily used by Stackage and Stack, hopefully other tools. Okay, so I've been ignoring Pantry, but I probably shouldn't have been because this is going to be, it says content addressable, right? So we're going to look up a package by its, by some like UUID or hash of some function that's not going to change and is uniquely going to identify a package. That said, I feel like content addressable stuff is more or less like a fancy key value store. So maybe we don't need to understand its inner workings too much. But we do get SQL stuff, SQLite, and whatever this is. Is this what is share? I don't know. But we can initialize project storage with project settings, config cache key. Yeah, so the cache key is presumably the to retrieve configuration or flag cache. And we're going to give it the file and a config cache type, and we're going to get the config cache key, and we're going to just call a unique config cache parent. Maybe we'll look at, I'm guessing that might be a pantry thing, defining the parent. All right. So basically a key, basically a key value store, I still think. Maybe if I'm misunderstanding pantry, then let me know. That doesn't mean it's easy, you know. That means we can black box it. That doesn't mean that it's not complicated or intricate in terms of its implementation. And then we're here in types, which we no longer need to be. And then Unix, we don't need to be here. So I'm going to call that, I'm going to call that a day. Where are we? We're about 2 hours, 20 minutes in. So that's stack. I don't know. I don't know if I have a summary. I guess that was the first Haskell, Haskell code base that we looked at, where it looks like it's doing some fancier stuff. Like we saw some transactional memory stuff, and it's got what appears to be like a bunch of I don't know if it's like applicative and like folding sort of stuff, just sprinkled throughout the code base. So so my sense is that to like look at some of those functions, some of the more complicated functions, you need to be like a little bit of more of a seasoned Haskell developer to have a really strong intuitive feel of like why the code is that way, or like, you know, maybe the right way to think about it is like you would look at one of those functions and be like, oh yeah, that's how I would do it too, that sort of thing. Like that's different from just being up, you know, from being able to look at it and saying like I kind of understand what's going on, which is a lower bar, but I guess a higher bar is looking at it and saying like, yeah, this is the obvious way to do it with these primitives or whatever. So I'm certainly not there yet. Maybe you are there, but it just kind of had a different flavor, I guess, than some of the other Haskell stuff we looked at. And that's Stack. So hopefully people found that fun. Tomorrow we're going to look at an open source Linux game, and then in the afternoon, I don't have an official time yet, but it will be on Twitch. I'll be playing a Disco Elysium, which is a video game, with my brother, and that'll be low key, just really hanging out, having a good time. Nothing at all like the exercise that is reading source code. So that's all for me, and bye.